Hi, welcome to Physics channel. Today let's discuss about the classification of nanomaterials based on dimensions. Nanomaterials are classified based on their dimensions into zero-dimensional nanomaterials, one-dimensional nanomaterials, two-dimensional nanomaterials, and three-dimensional nanomaterials. In the zero-dimensional nanomaterials, all the dimensions are less than the 100 nanometer. In one dimension, only one, either the length or breadth or the height, is larger than the nanoscale, and the remaining two dimensions are less than the 100 nanometer or equal to 100 nanometer. In two-dimensional nanomaterials, two dimensions are larger than nanoscale, and the remaining only one dimension is less than the 100 nanometer. So let's discuss zero-dimensional nanomaterials. In zero-dimensional nanomaterials, as we said, all dimensions are less than or equal to 100 nanometer. So we have seen here the particles which are confined in all the directions, in x direction, y direction, and z direction. That means if we compress a material in all the dimensions, we will get this type of structure. These are the nanoparticles. So when you see the example for this zero-dimensional nanomaterials, one is the carbon ion and nanoparticles. So what are the properties of nanoparticles? Nanoparticles can be the amorphous or crystalline. They may be of various shapes and forms. They may be of metallic or polymeric or ceramic. And another example is quantum dots. You can see in the figure, these specimens have different colors is due to the vary in particle size. Suppose the 2 nanometer particle appears blue for us. 4 nanometer CDSC nanoparticle appears green in color, and the 6 nanometer CDSC nanoparticle appears red in color. What is a quantum dot? Any solid material in the form of a particle with a diameter comparable to the wavelength of the electron is a quantum dot. We can give an example, the CDSC particle. What are one-dimensional nanomaterials? As the name indicates, it has one dimension. Which is that one dimension? Either it may be the length or breadth or height, any one, not three. One dimension is larger than the nanoscale. The remaining two dimensions are less than or equal to nanometer. Example, nanowires, nanotubes, and nanorods. You might have observed the wires. In the same manner, the nanowires also appear. Nanowires are wire-like structures whose diameter is very less compared to its length. Any solid material in the form of wire with a diameter smaller than about 100 nanometer, example, indium phosphide or indium arsenide nanowire. Another example we can give is the nanotube. So what is a nanotube? Structures that are only a few billionths of a meter in diameter. Example, carbon nanotube. The prototype of nanotube is, you can imagine the refill of a pen, which is less in diameter and the length is more. Another example is gold nanorods. See, these are the rod-like structures. Diameter is very less and the length is more. Let's discuss the two-dimensional nanomaterials. So here, as the name indicates, two dimensions are larger than the nanoscale, and the remaining only one dimension is less than or equal to 100 nanometer. So what are the examples for the two-dimensional nanomaterials? One is the graphene sheet, nanofilm, some nano layers, and nano coatings. So you can see the graphene sheets which can be used to produce the carbon nanotubes. Here also you can observe the nanofilm, which is the film like structure which is two-dimensional, and here also the nano layer, it is the layer example for the two-dimensional materials. You can see the two dimensions here, one is the length and another one is the breadth. You can see in this nano coating, when it is coated with the nanomaterials, the droplets of water not percolated into the surface of the material. So droplets are perched only on the surface itself. So let's come to the 3D nanomaterials. So 3 dimensions are outside the nanoscale. These are not confined in any direction. So example for 3D nanomaterials is the bundles of nanowires. Let's consider only one wire which is only 80 nanometer diameter and the length is very large, and if we bundle all these types of wires, we will get in nano wire bundles. Here the diameter of this nanowire bundle is 600 nanometer. Another example, we can take the multi-nano layers. Layers are placed one over the other. It forms a three-dimensional multi-nano layers. Thank you for watching.